Hello students, I am Rajni Verma and in this video I am going to plot and explain the interpretation of graph. I have taken in-text questions from NCERT book. These two questions are often not solved by teachers as well as students. Now let us take the questions. Here we take a question from activity 8.9. That is page 106. It says the times of arrival and departure of a train at three stations A, B and C and the distance of stations B and C from station A are given in table 8.4. So here is the table and then plot and interpret the distance time graph for the train assuming that its motion between any two stations is uniform. So we see that there are three stations A, B and C. A train arrives at station A at 0800 hours, halts there for 15 minutes till 8:15 hours and then it departs from station A and reaches station B at 11:15 hours. Station B is at a distance of 120 kilometers from station A. There again it halts for 15 minutes till 11:30 and at 11:30 hours it departs for station C, which is at a distance 180 kilometers from station B. It reaches station C at 13 hours and there again it halts for 15 minutes till 13:15 hours. We have to plot a distance time graph for the train and then interpret the graph. For the sake of simplicity and ease for plotting the graph, I have rewritten the data. It is very convenient if we write the data in this form. Time in hours, distance in kilometer, 0800 to 13:15 hours. Distance in kilometer, 0000, 120, 120, 180, 180. And as we can see, the train is at rest between these two observations. It is at station A, here it is at station B, here at station C. The times and the distances marks in red denote the interval and the distance traveled during the journey from A to B and from B to C. So let us calculate the range and scale. The most difficult part here is to choose the range and scale, to find the range and to choose the scale, since time is not given in very simple manner. So let us see, time is from 0800 to 13:15 hours. So in total it is 5 hours 15 minutes. 13 minus 8 is 5 and this is 15. 5 hours 15 minutes. So if we look at the scale, since 15 minutes come 4 times in 1 hour, we have 5 into 4 plus 1, that means there should be 21 units. So whatever unit, whatever scale we choose for the scale, for the graph, say 10 small divisions is equal to or 1 small division is equal to whatever, it should be a multiple of 21 so that the whole of the data fits on the graph. For distance, it is very simple. From 0 to 180 kilometer, we can choose any multiple of 10 or 20 or say 60, anything like that. So when we plot the graph, this is the actual graph drawn on a graph paper. And here is a rough sketch for explanation. In order to calculate the speed of the graph, we will have to find the slope of the distance time graph. From O to P, the train is at station A. From Q to R, it is at station B. From S to T, it is at station C. So, from A to from station A to B. From station A to B. That is the points P to Q. The speed is equal to the slope, that is QD upon PD. QD upon PD. QD denotes the distance. This is 120 minus 0, 120 kilometers, and time is from 8:15 to 11:15, that is 3 hours. So the speed is 120 upon 3, that is 40 kilometer per hour. Similarly, from station B to C, the part of the graph is R to S. RS, we have speed is equal to SF upon RF. Now this SF is SG minus FG, or we can see directly SF, that is between station B to C. Between station B to C, it is from 120 to 180, that is 180 minus 120, 60 kilometers. This is 60 kilometers divided by the time taken is 11:30 to 13:00. That is 1.5 hours. 1.5 hours. Now if you simplify 1 upon one whole number 1 by 2, that is equal to 3 by 2. When we write this, it is 60 kilometers. Let us write it like this. 60 divided by 3 and multiplied by 2. That is kilometer per hour. So that it is 20 times, it will be, 20 times, and 20 into 2, that is 40 kilometer per hour. So we see that the speed in both cases, that is the train moves with a uniform velocity and the same velocity from station A to B and then again from station B to C. We can see that the speed here is actually an average speed, because from 0 to maximum speed and then again to 0, when it stops, the motion cannot be uniform. There must be some acceleration when the speed of the train increases and then when it decreases before coming to halt. But for calculation, we have taken it as 40 kilometers per hour. This is the average speed of the train. Let us take a question given in activity 8.10 at page 107. Activity 8.10. The question says, Firoj and his sister Sania go to school on their bicycles. Both of them start at the same time from their home but take different times to reach the school, although they follow the same route. Table 8.5 shows the distance travelled by them in different times. Plot the distance time graph for their motions on the same scale and interpret. So here we have the question and the actual table given. Since time is given in AM and the observations are at the time intervals of 5 minutes each, we can rewrite the data in this form. At 0 minutes, the distance travelled by Firoz is 0 kilometers, by Sania also is 0 kilometer. Then at intervals 5, 10, 15, 20 and 25 minutes, these are the respective distances travelled by them. Now we plot a graph. Here you can see the actual graph drawn. Now let us calculate the speed of the two siblings. For Firoz, we can write for Firoz speed is equal to, as we know, speed from a distance time graph can be calculated from its slope. So here slope is equal to, look at the graph, PR upon OR, that is 3.6 kilometers divided by 20 minutes. Now we change this 20 minutes into hours. So 20 minutes divided by 60 is equal to 20 minutes divided by 60 is equal to, say, 1/3 hours. So we can write 3.6 divided by 1/3, that is 3.6 divided by 1 multiplied by 3, and this will be kilometer per hour. So this is 10.8, yes, 10.8 kilometer per hour. Let us denote it by VF, speed of Firoz. For Sania, we can calculate it. Okay, for Sania, we have VS is equal to, again, slope, and this slope is from the graph QR divided by OR. This is equal to 3 kilometers divided by, again, 20 minutes, that will be 1/3 hours. This is equal to Vs is equal to 3 upon 1 into 3 is equal to 9 kilometer per hour. So we can see that the speed of Firoz is greater than the speed of Sania. So students, I have tried to explain the answers completely and I hope it is useful for you. In my next video, I will take exercise questions from your book. If you like this video, please like, share and subscribe to my channel. Thanks for watching.